In this video, we'll discuss the communications critical infrastructure sector and cybersecurity. This video is brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. NCyTE Center in this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I am a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida. So in this video, we'll discuss the following. First, we'll describe the communications critical infrastructure sector. We'll describe what that sector encompasses. We'll show how the sector relates to several other critical infrastructure sectors. We'll discuss general threats to the communications sector. We'll discuss government plans for protecting communications in the U.S. We'll demonstrate examples of actual events that have affected communications. We'll discuss how the communications attack surface is expanding through the Internet of Things. And finally, we'll have a wrap-up. The Cybersecurity and Infrastructure Security Agency, or CISA, includes the communications sector as one of the 16 critical infrastructure sectors in the United States. It's an integral component of the U.S. economy underlying the operations of all businesses, public safety organizations, and government. Over the last 25 years, the sector has evolved from predominantly a provider of voice services into a diverse, competitive, and interconnected industry using terrestrial, satellite, and wireless transmission systems. The transmission of these services has become highly interconnected. Satellite, wireless, and wireline providers depend on each other to carry and terminate their traffic, and companies routinely share facilities and technology to ensure interoperability. The communications sector infrastructure that connects the world's communication networks, that is the fiber and switches that carry the calls and data from one point to another, is the same infrastructure that delivers malware to unsuspecting users and enables hackers to take control of computers remotely. The failure to protect communications infrastructure compromises all other facets of the digital age, including other critical infrastructure sectors. As such, the communication systems are the backbones for information exchange, including voice, data, video, and internet connectivity for all other critical industry sectors within the United States and actually all over the world. So communications encompasses 5 industry segments, which is shown on the screen here. The first is broadcast, which consists of free and subscription-based over-the-air radio and television stations that offer audio and video, programming services, and data services. Then we have cable, which consists of systems that offer video programming services, digital telephone, and high-speed broadband services. We have satellite, which includes platforms launched into orbit to serve a variety of functions, such as the bidirectional transmission of voice, video, and data services, data collection, event detection, timing, and navigation. We also have wireless, which refers to telecommunications services in which the spectrum is used to carry signals over a part of or the entire communications pathways. And finally, we have wireline, which refers to wired connections that include private enterprise data and telephone networks, the core backbone of the internet, and public switch telephone networks. Now, when we hear the word communications, I think that most of us think of personal telephone calls or texting, messaging, or watching streaming cable video shows and the like. However, it is much more than that. As alluded to in a previous screen, the communication sector is highly connected to several other sectors. For example, the General Accounting Office reported in November 2021 that CISA determined that the communication sector depends on other critical infrastructure sectors, in particular, energy, which provides power to run cellular towers, central offices, and other critical communication facilities, and also relies on communications to aid in monitoring and controlling the delivery of electricity. Information technology, which provides critical control systems and services, physical architecture, and internet infrastructure, and also relies on communications to deliver and distribute applications and services. There's also the financial services sector, which relies on communications for the transmission of transaction and operations of financial markets. The emergency services sector, which depends on communications for directing resources, coordinating response, operating public alert and warning systems, and receiving emergency 911 calls. And also the transportation systems sector, which provides the diesel fuel needed to power backup generators and relies on communications to monitor and control the flow of ground, sea, and air traffic. Damage, disruption, or destruction to any of these sectors could severely impact the operations of the communications sector. What I'm alluding to here is there's really a bi-directional relationship between the communications sector and all the other sectors that you see on the screen. What do I mean by that? Well, we've always seen that the communication sector is an important part of the energy, information technology, and transportation sectors. Not included on the screen are the emergency services sector and financial services sector, but pretend they're there. But also, as it turns out, is that these sectors, the energy, information technology, and transportation sectors, also have an effect upon the communication sector. So whatever happens to any of the sectors on the right also has an effect on the communication sector. So essentially, critical infrastructure sectors can have a codependent or symbiotic relationships. Issues with one sector can have a cascading effect on other sectors, which means that if we want to protect the communication sector, we also have to protect the energy sector, the information technology sector, and transportation sector, and that's a bilateral relationship. To protect one, we have to protect all the sectors. So what is the government doing to protect critical infrastructure? Well, each critical infrastructure sector has something called a sector-specific plan that focuses on the unique operating conditions and risk landscape within that sector. Developed in close collaboration with federal agencies and private sector partners, the sector-specific plans are updated every 4 years to ensure that each sector is adjusting to the ever-evolving risk landscape. And that comes directly from NCyTE.gov. So what are some examples of potential security threats to the communication sector? Well, they can be divided into 3 areas. The first is physical, such as natural occurrences like hurricanes, floods, and ice storms, or human-made occurrences such as explosive, chemical, biological, or radiological contaminant attacks on communications network infrastructure and personnel. Then there's cyber-related threats, such as malicious actors, adversaries who intentionally disrupt the systems on a communication network, or non-malicious actors, such as employees that accidentally alter a communication network's configuration, negatively affecting the network's ability to function properly. And finally, there's the human threat. Threats to a communications network due to the failure of employees to plan for security incidents and implement protocols to protect networks from the impacts of such incidents. Now, normally when we think of cybersecurity, all we're thinking of are those cyber-related threats. But let's see why that's a very limited view of protecting the information that we desire to protect in cybersecurity. For example, on the previous screen, we saw that physical threats are a threat to the communications sectors. How can a physical threat be a part of cybersecurity? Well, it absolutely is, and here's why. Now, I've already discussed several properties of information that we wish to protect, and those are confidentiality, integrity, and availability. Confidentiality means that data should only be accessed by those who have a right or need to access it. Integrity means that data should remain in its true state and should only be changed by those who are authorized to change it. And finally, there's that word availability, which means that data should be available to users when they have the need to access it. And so if we look back at the physical threats to communications sectors, hurricanes, floods, and ice storms are physical events. And if they bring down the communication systems, that means that that information would not be available. And the same thing goes for human-made occurrences as well, even though those threats are unintentional. A threat doesn't have to be intentional. It doesn't have to be something that comes from a malicious actor. It's those 3 properties of information, confidentiality, integrity, and availability, that we want to protect, regardless of the source of the threat. So as we discussed on a previous slide, the government updates their sector-specific plans supposedly every 4 years. But the General Accounting Office study found that the CISA has also not updated the 2015 Communications Sector Specific Plan, even though the Department of Homeland Security guidance recommends that such plans be updated every 4 years. And since I'm making this video in 2022, that means that these plans are about 7 years old, well past the 4-year limit. The current 2015 plan lacks information on new and emerging threats to the communications sector, such as security threats to the communications technology supply chain and disruptions to position, navigation, and timing services. Let's take a look at those 2 threats. Let's discuss the definition of supply chain. A supply chain is a network between a company and its suppliers to produce and distribute a specific product to the final buyer. This network includes different activities, people, entities, information, and resources. The supply chain also represents the steps it takes to get the product or service from its original state to the customer. So if you were alive in 2020 through 2022, you know that the COVID-19 pandemic had a great effect upon the world, its people, and its economy. A secondary effect of COVID-19 was it had a great effect on the disruption of our supply chains, which meant that we couldn't get goods and services from the suppliers to the intended users. And a good example of this occurred in 2021 when large container ships were unable to dock at port. Whether you are aware or not, a lot of the goods we get and we use every day are from overseas. In fact, a lot of it comes from China. A lot of these goods come over on large container ships. However, because of large shutdowns across the United States and a lot of people being sick, ports were unmanned. And so what occurred is that these container ships were left sitting out in the ocean for weeks upon weeks because they were unable to dock at port because there weren't enough dock hands to remove the containers off those ships so that then they could be trucked to their intended locations. How big a problem is this? Well, let's look at one of these container ships right here. The TEUs are essentially each of those containers, and while those containers may look small, if you've ever been on the road and you've seen an 18-wheeler with one of those, that's the size of them. So although they look small, they're actually very large. This container ship alone can carry almost 24,000 of those containers. And of course, within those large containers may be hundreds or thousands or millions of different products that are going to various places throughout the United States. This is a graphical depiction at one point in time via marine traffic showing the Port of Los Angeles and Long Beach and how many container ships were sitting out in the ocean, unable to dock at port, unload the ships, and have those containers picked up by trucks that then carry them to their intended locations. If you want more information about cyber supply chain risk management and supply chains, NCyTE has a series of 3 YouTube videos on cyber supply chain risk management. Now let's go back to the other threat that was noted in the General Accounting Office study, and those are disruptions to position, navigation, and timing services. And there's quite a few critical systems that use GPS. For example, aircraft when they're flying, self-driving cars, which are becoming more common, as well as ships. Those are just a few of the systems that are used. And these are the commercial applications that use GPS. There's also military applications as well. So what are some threats to GPS? Well, MITRE did a study and it identified several threats to GPS, some of which are intentional threats, that is intentional attacks, and then there's unintentional. So let's look at some of the unintentional threats to GPS. For example, radio interference. If you have a system that's using the same radio frequency spectrum as GPS, that can unintentionally interfere with the GPS data. There's also something called space weather. Did you know that there's space weather and that the sun's solar flares can actually disrupt GPS? Or there's unintentional jamming, which is kind of similar to RF interference. You have a system who puts out some sort of radiomagnetic signal which ends up interfering with the ability to read from the GPS satellites. Then you have intentional threats. For example, intentional jamming. All militaries use GPS, and a part of electronic warfare is jamming those GPS signals so your adversary can't use this. That's being used in the current Ukrainian-Russian conflict. Finally, you have something called spoofing, which essentially means a malicious actor is intentionally creating GPS signals which are false. And finally, you have your basic old cyber attack, which runs the gamut from malware to distributed denial of service attacks. If you want more information about GPS spoofing and jamming, NCyTE has 3 YouTube videos that touch on global positioning systems, which are sometimes called global navigation satellite systems. And those are contained within my small unmanned aircraft system videos. Now, one of the problems with the government protecting critical infrastructure is that the government doesn't own it. About 80% of critical infrastructure in the U.S. is owned by private parties. And in its current state, there are no laws that require private entities over all the critical infrastructures to protect those infrastructures which they own. So there's only a limited amount of leverage that the government can apply to the private entities to lead them to protect that critical infrastructure. How are you and I increasing the likelihood of communication cyber-based threats? Well, we're doing that through something called the Internet of Things. First, let's explain what I mean by the Internet of Things, or IoT. IoT is the concept of connecting any device, as long as it has an on and off switch, to the internet and to other connected devices. IoT is a giant network of connected things and people. all of which collect and share data about the way they are used and about the environment around them. And whether you realize it or not, most of us in developed third world nations are already reliant on IoT technology, and we really don't realize it because it doesn't come at us all at once. It's a very slow process of adding one system here, one system there, so we really don't realize how reliant we are on IoT until something goes wrong. For example, an IoT device, a smartphone. I don't know anybody who doesn't have a smartphone. We have things called smart home assistants. We have Alexa, Google, Apple. We have smart thermostats which we connect to the internet, so when we're away from home we can set our thermostat at home. We have security cameras, so we're able to watch what's happening in the security camera when we're away from home, and we do that through our smartphone. We even have silly things. Well, I'm sorry, silly to me, a smart refrigerator. I'm not sure why we want a smart refrigerator, but anyway, these connect to the internet, and so when you're at the office or your school and you want to see if you have any milk, you can log into your app that connects over the internet into your home network, which then connects to your refrigerator to see if you need to order milk. We even have things like smart light bulbs that you plug in. You can schedule the setting for turning it on, turning it off. You control it over Wi-Fi through your remote control through an app on your phone. You can adjust the color. You can use voice control through Alexa or Google Home or the Apple Home Assistant. But each one of these is essentially a little mini computing device that plugs in to your network. Every time you plug something in that has an IP address, you're increasing the potential attack surface of your home, at least in this instance. So you may be thinking, big deal, right? What does this have to do with me? Imagine you're in your brand new $90,000 Tesla, which probably has hundreds or thousands of chips, and it creates its own little network, and it connects to a satellite 18,000 miles above the United States, which then connects to back-end computers that's feeding data to and from your car. Also, modern airplanes are essentially flying computers. They have networks, they have thousands upon thousands of computer chips, and they're highly reliant upon the information communication technologies that underlie their systems. Even ships are essentially floating computers. Every time we connect to the internet, we're relying upon the communications critical infrastructure sector. If anything affects that communications sector, it also affects us. We even have things called smart cities, which have IoT-enabled factories, shops, airports, stations. These are all connected to data centers. We have homes and office buildings that we call smart office buildings. All of these collapse into something called smart cities or IoT-enabled cities. We are becoming more reliant on the communications sector because of the increased reliance on the Internet of Things. Now let's look at a small example of how all these systems that we've discussed before, these Internet of Things systems that are sitting in your house, may work together. For example, imagine you wake up at 7 a.m. every day to go to work. Your alarm clock does the job of waking you just fine. That is, until something goes wrong. Your train's canceled and you have to drive to work instead. The only problem is that it takes longer to drive, and you would have needed to get up at 6:45 a.m. to avoid being late. Oh, and it's pouring rain, so you'll need to drive slower than usual. How could IoT help? Well, a connected IoT-enabled alarm clock would reset itself based on all these factors to ensure you get to work on time. It could recognize that your usual train is canceled, calculate the driving distance and travel time for your alternate route to work, check the weather, and factor in slower traveling speed because of heavy rain. It could also calculate when it needs to wake you up so that you're not too late. If it's super smart, it might even sync with your IoT-enabled coffee maker to ensure your morning coffee's ready to go when you get up. Now, this sounds like something out of the Jetsons, which was a cartoon from the 60s, but we are on a path to being fully entrenched in an Internet of Things. And so a lot of what I talked about was kind of futuristic, but currently industry is using IoT heavily. For example, it's used in remote monitoring. You can monitor almost any kind of asset, including heavy machinery, vehicles, and even livestock, almost anywhere, either continuously or at regular intervals. By tracking location, performance, condition, or environmental factors, the insights you gain from IoT-connected devices may help you make better decisions. It's also used in predictive maintenance. Similar to remote monitoring, predictive maintenance incorporates machine learning software that analyzes data to predict outcomes and automate actions. It's also used in facilities management. This is focused on monitoring your buildings, infrastructure, and other spaces, allowing you to improve energy efficiency, space utilization, productivity, and safety using the data that you collect. It increases manufacturing efficiency. Every business is different, but many manufacturing processes share a common pathway from raw materials to finished products. With IoT, it's possible to learn from your own systems to find new ways to manage your processes and product quality with data from your devices and sensors. And finally, connected products. Connected products have smart, connective components that allow data to be exchanged with the product and its user, manufacturer, or environment. Related IoT solutions may help you find smart factories with new functionality, greater reliability, and higher product utilization. If you want to know more about how IoT could be used in industry, YouTube channel has 2 videos on advanced manufacturing, which uses IoT technology for industrial control and monitoring. Now, to summarize, we discussed communications critical infrastructure sector serves as the backbone for many other critical infrastructure sectors. We discussed that communications includes your personal phone, messaging, cable, and streaming video, but it's actually much more than that. We looked at the fact that there's a symbiotic relationship that exists between communications, energy, information technology, financial services, emergency service, and transportation sectors. We discussed the Internet of Things and how it has increased the reliance on the communication sector, and the fact that IoT is used not only by the public, but also used in remote monitoring, predictive maintenance, facilities management, manufacturing efficiency, and connected products. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.